You know that feeling, right? That little pang of panic when you see the low battery warning pop up? Well, what if that feeling could become a thing of the past? In this explainer, we're going to dive into a technology that promises to do just that, spark a real revolution in how we power our entire world.
All right, let's start with a problem that, let's be honest, connects every single one of us every single day.
We all know this drill. It's that constant nagging battery anxiety. You know, the daily hunt for a wall outlet, the frustration of being literally tethered to a charger, and just the sheer annoyance of having a device that just can't keep up with your day.
And it's all because for years, we've been forced to accept the fatal flaws of lithium-ion technology like it's normal. I mean, charging takes hours. The battery capacity starts to fade after just a couple of years. There's a very real fire and safety risk, and all of it just contributes to this growing mountain of e-waste. It's a broken system.
But what if we didn't have to accept this broken model? What if there's a fundamentally better way? And that, right there, brings us to the breakthrough at the very heart of our story today.
So, let me introduce you to the hero of this explainer, the LGE Hybrid Super Capacitor. Now, this is not just a slightly better battery. No way. This is a whole new category of energy storage. It brilliantly merges the best of both worlds. You get the long-lasting energy of a battery, but with the insane power and speed of a supercapacitor. So what does that actually mean for you? Well, first, we are talking about unparalleled longevity. Just imagine a battery that you can charge and discharge over 10,000 times with almost zero performance fade. It would literally last the entire lifetime of whatever device it's in. Second, and this is a huge one, safety. It uses something called a liquefied gas electrolyte. Now, the easiest way to think about this is like having a built-in fire extinguisher right at the molecular level. It makes the whole thing non-flammable. This completely eliminates that risk of fire and thermal runaway that plagues so many of the batteries we use today. And third, okay, this is the absolute game changer, speed. We are not talking about fast charging that gets you to 80% in half an hour. We are talking about a full charge in a matter of minutes. Or, for smaller devices, we could be talking seconds. This completely rewrites the definition of fast. Okay, so that all sounds incredible in a lab, right? But what does a world with this tech actually look like? Let's take a look at how it could completely transform the devices and systems we rely on every single day. Let's start with our personal electronics, like your laptop. The upgrade is just massive. Imagine your charge time dropping from hours to minutes, a battery that doesn't just die after 2 or 3 years, and, of course, zero fire risk. This isn't just an update, it's the end of planned obsolescence for batteries. Okay, now let's apply that same thinking and scale it way up to electric vehicles. Just picture this. You pull into a charging station and you refuel your EV in the same 5 or 10 minutes it takes to pump gas. I mean, this technology directly tackles the single biggest hurdle that's been holding back mass EV adoption. And believe it or not, it gets even better. Because of its unique design, we're also talking about a massive reduction in weight. A 50 kilowatt-hour LGE pack weighs a tiny fraction of its lithium-ion counterpart. And a lighter car is a more efficient car, which means you get way more range out of every single charge. It's a win-win. But the impact here goes so much further than just our personal devices and our cars. This technology is really designed to scale up and help solve the energy challenges of the entire planet. You see, for renewable energy to truly work on a global scale, you need storage that is dependable, super safe, and built to last. This system, it delivers on all fronts. It can handle the deep, daily cycling of solar power for decades. It's safe enough to install in your home. And it even has a self-powered monitoring system to make sure it's always on, always reliable. And let's just look at that long-term value. I mean, even the best lithium-ion batteries out there top out around 8,000 cycles, which might give you 15 years, if you're lucky. The LG Super Capacitor is guaranteed for over 10,000 cycles. That translates to a lifespan of over 20 years, making it the clear default choice for huge infrastructure projects. So you're probably wondering, just how big is this opportunity? The scale of it is almost hard to wrap your head around. We are not talking about competing in one market here. We are talking about disrupting 3 massive global industries all at the same time. You've got automotive batteries, stationary grid storage, and consumer electronics. And each one of those is an absolute giant on its own. So when you add all of that up, you get a total addressable market of over $1.6 trillion. Let that sink in. This isn't just a replacement product. This is a replacement platform for an entire technological ecosystem. A market that big requires a seriously aggressive strategy. And this manufacturing plan shows exactly that, scaling to 35 gigawatt hours in just 3 years. And the focus is crystal clear. Hit the biggest markets first, automotive and grid storage, to drive massive, rapid scale.
And that kind of scale, it translates directly into value. Just based on being able to command a premium for this far superior technology, the intellectual property alone is projected to bring in over $1.2 billion in revenue. And that's just within the first 3 years of production.
But you know, the revenue is only part of the story. The real prize here is the strategic value. This IP doesn't just create a product, it creates a technological moat. It makes the company a must-have acquisition target for global players. It builds a permanent barrier to keep competitors out, and it secures a supply chain that is totally free from volatile materials like cobalt. Which brings us to a final thought. For decades, innovation has been held back, constrained by the fundamental limits of our batteries. So when those limits, on speed, on safety, on lifespan, are finally removed, what new possibilities open up? What could we create when our power is truly limitless?